Okay. Now in my fifth video, I want to show that whether 4 pi should be used or not for radial distribution function of hydrogenic system. That is, we want to know that radial distribution function, or this is called radial probability distribution function, or this is also called radial probability density distribution function. So we have to know what is the correct expression for the radial distribution function. So for this, we have taken a system. We have a system that is hydrogen atom or any single electron atomic species like He plus, lithium 2 plus, barium 3 plus, etc. Single electron atomic species, not H2 plus. Okay. Then for radial probability distribution function, expressions are in various text view, that is written as r square, somewhere written as 4 pi mod psi square r square, somewhere 4 pi r square, in some book that is psi square r square. Which one is correct or which is r correct? Then for this, first of all we take r square, and what happened for this? This is correct or not? I have to see. R square. For this expression, I have to take a radial function. So simplest state is 1s state. So we take the radial function of this 1s state, we call 1 0, because n is 1 and azimuthal quantum number, that is 0. So 1 0, that is represented as radial function r10. The expression is r10. Expression for this radial function is 2 times z by a naught to the power 3 by 2 e to the power minus zr by a naught. This is given in any textbooks. So you take this r10, where z is nothing but atomic number. So simplicity, I have taken hydrogen atom and we use z is equal to 1. And a naught is nothing but this is Bohr's radius, and this is equal to 0.529 angstrom. So this is a constant. So I have taken z, that is 1 for hydrogen atom, and state is 1s, so R10, that is its representation. Radial function, this is normalized radial function, normalized radial function. Now, if a radial distribution function is r square, then r square 10 r square dr 0 to infinity, this integration should be 1. If this is the expression for radial distribution function, then this is equal to 1. Now, we put the value of R10 that I have written here. So R10 is that 2 times 1 by a naught. I have taken z is equal to 1, and this is a square here, so 3 by 2 and e to the power minus z r by a naught, and z is 1, so put 1 here, and a square and r square dr, that I have to know what is the value. So by squaring, this becomes 4 times 1 by a naught cube, and then e to the power minus 2r by a naught and r square dr. This is equal to what? So we know that 0 to infinity, if the integrand is r to the power k and e to the power minus some constant and r dr, where k is positive, I have taken, then this is equal to, this integration becomes, this is general knowledge, this integration becomes gamma k plus 1 divided, this is the constant, neglect negative sign here, this is constant, and power is k plus 1. So this is your integration. Now here the k is nothing but 2, so this becomes 4 into 1 by a naught cube into, this becomes gamma 3 divide, the constant is except r 2 by a naught, this is your constant 2 by a naught, and power is 3. Now gamma 3 is equal to factorial 2, and factorial 2 is equal to 2 into 2, that is 2. So this is 4 into 2 divide a naught cube into 2 to the power 3, that is 8, and a naught cube. So this becomes 1. So it is clear that for ns function, I have taken ns function for example. So for ns function, r square is radial distribution function. nothing I have to learn with the 4 pi. 4 pi is extra term here. So that is not taken here. This is r square. It is sufficient for the radial distribution function, for ns function. Now check for the np function, nd function. So for simplicity, I have taken one example, another one example, that is for np state. Okay, that is 2p state. 2p state. Then radial function for 2, 1. This subscript represents the n value 2 and L value 1. That is for 2p state. So radial function, this is also taken from any textbook. R2p is equal to 1 by root 3 z by 2a naught 3 by 2 zr by a naught e to the power minus zr by 2a naught. This is the normalized function I have taken from the textbooks. So 1 by root 3 z by 2a naught to the power 3 by 2 zr by a naught into e to the power zr by 2a naught. This is the radial function for 2p state. Normalized function. This is a normalized function. Okay. This is a normalized function. I have to check for this function, radial distribution function is r square or not. I have to check this. Check. So the mathematical expression for this is r square dr 0 to infinity must be equal to 1. Then this is the radial distribution function. Then we call this is the radial distribution function, otherwise not. So I have to prove that this is equal to 1. Now we calculate r square for the 2p state. Hence r square, this becomes 1 by root 3. For simplicity, z is 1, 2 by a naught and 3 by 2 and r by a naught and e to the power minus zr by z, that is 1 here, and z, that is 1, and r by 2a naught. This is your function, that is r21. This is r21. So I have to square this, and another term is r square dr, and 0 to infinity. What is the value? So by integration, for integration 1 by 3, by squaring this becomes 1 by 3, and this becomes 1 by 2 by a naught to the power 3, and then this becomes r by a naught to the power 2, and e to the power minus r by 2 a naught, that is multiplied by 2 because squaring, and r square dr 0 to infinite. This is constant term, and now another constant term a naught is also here. So this becomes 1 by 3 into 1 by 8 a naught cube into, take a naught also here constant, so 1 by a naught, and then this is 0 to infinity, and r square, this is r to the power 4, and now this is cancel out. So e to the power minus r by a naught dr. This is the integrand. So the integration of this is again, this is equal to gamma 4 plus 1, that is 5, divided constant, that is 1 by a naught here, except minus r, that is 1 by a naught here. So 1 by a naught to the power 5. This becomes factorial 4 into a naught to the power 5. So 1 by 3 into 1 by 8 a naught cube into 1 by a naught square into a naught to the power 5 into 4 into 3 into 2 into 1. That is your factorial 4. So 3 is cancel out, 8 is also cancel out, and this all goes to become 1. So again we see that for 2p state also, r square is the radial probability distribution function. So there is no need of 4 pi here. So 4 pi r square for 2p state is also not valid function. R square is sufficient to describe the radial distribution function or radial probability distribution function. Hence you can check for 3D also. So let us start. Take an example for 3D. For 3D, the radial function 32 is equal to 4 by 27 root 10 into 3 by, that is z by 3a naught to the power 3 by 2 into z square r square by a naught square into e to the power minus zr by 3a naught. Okay, this is 3D state. So this is normalized state here. Now for r square, this becomes 16 by 27 square into 10, and this becomes 1 by 3a naught to the power 3, and this becomes, this is 1, so r square a naught square, and this becomes 1 by a naught to the power 4 by squaring this, and r to the power 4 is in integrand, and e to the power minus z is 1, so 2 times r divided 3a naught, and another term r square dr is also here. So 0 to infinite, and this is what? So I have to prove that this is equal to 1. Then this is sufficient expression for the radial probability distribution function. Let us see what happened. Then this calculation, 16 by 27 square 10 into 1 by 27 and a naught to the power 3 and a naught to the power 7, take here a naught to the power 7, and this is r to the power 6, r to the power 6 and e to the power minus 2r by 3 a naught dr, 0 to infinity. The integration of this integrand becomes gamma 7 by 2 by 3 a naught to the power 7. Okay, and this is equal to factorial 6 and by 2 to the power 7 into 3 to the power 7 and a naught to the power 7. So this becomes 16 by 27 square into 10 into 1 by 27 and a naught to the power 7 into this is 3 to the power 7 and a naught to the power 7 by 22 to the power 7 and factorial 6. This is equal to 6, 3, 2, 6, 3, 2, 5 also, 4 also and 2, 6, 4, 5 and 3, 2. Okay, this is factorial 6. Now, this is 27 to the power 2. So, you can take here 3 to the power 8, this is 3 to the power 7 and this is 3, so 3 to the power 8, that is 3 to the power 3 into 3 to the power 3 into 3 to the power 2. So this is gone here and this becomes 3 to the power 3, 3 to the power 3 and 3 to the power 2. So one factor is here, this cancel out and 3 to the power, here is also 6 and this is 2. So I can take this as 3 into 2 to the power 2. So this becomes 3 to the power 3 and 3, so 3 to the power 3 also. So this is 3 to the power 3 and now 27 square also on. Now this is 2 to the power 2 and I have taken this, so 2 to the power 5, this is 5, so 5, 2 times 5. Now this becomes 4 and this is 2 to the power 2. So this is 2 to the power 4. So this becomes 2 to the power 4, 2 to the power 2, 2 to the power 4, 4, 8. So 2 to the power 8, total 2 to the power 8 here, and this is also 2 to the power 8. So by cancel out all things, that it becomes 1. You can verify this. Okay, you can verify this. You can verify. This is also 1. So here we have seen that in case of NS state, in case of NP state, in case of ND state, and you can take any other state, if radial function is given, then r square term is sufficient to describe the radial probability distribution function. So for r square, no need of 4 pi. This is extra term. Hence, radial probability distribution function is r square. It is clear that one function I have taken here, that is r square, it's defined the radial distribution function. That is clear here, that this function describes the radial distribution function. Now this is wrong, because we get always 4 pi, but answer is 1. So that is not true. So 4 pi r square is not the radial distribution function. Now check this function, that is 4 pi mod psi square r square. This is true or not? Okay. Then again we have to take ns function. Ns function, and I have to check that 4 pi mod psi square r square, this is a radial distribution function, radial distribution function or not. I have to check this. So for this I have taken psi 1s. This is psi 1s, not r1s. This is not r1s. This is psi 1s, because psi 1s is psi 1 0 0. Okay, where n is 1, l is 0, and n is also 0. This is r theta phi function. Okay, this is r theta phi function. So 4 pi psi square, this is taken for psi 1s. What is psi 1s? You get any textbook, and then the psi 1s is 1 by root pi and z by a naught to the power 3 by 2 and e to the power minus zr by a naught. This is your function, psi 1s function. Now what is psi 1s square? That is mod psi square. So psi star psi, this is mod psi square, and we see here that this is the real function. This is the real function. So this is simply psi square. Hence the integration of this 4 pi and psi square, this is equal to 1 by pi into z by a naught, 1 by a naught to the power 3 into e to the power minus zr, that is 2r by a naught, because by squaring this multiply with 2, and another term, that is r square dr here, and 0 to infinite. And what is the answer? That I have to see. So for this function, for this integrand, the integration is that 1 by 4 pi, 1 by pi, and now this is 1 by a naught to the power 3, and integrand is your e to the power minus 2r by a naught into r square dr. This is your integrand. Now integration of this is what? So pi then 4 into 1 by a naught cube into this becomes gamma 3 divided 2 by a naught to the power 3. So this is equal to 4 into 1 by a naught to the power 3, and this is a factorial 2 divided 8 into a naught cube. So by cancel out, this becomes 1. Now again here we see that for ns function 4 pi mod psi square r square, this is the probability distribution function, radial probability distribution function. So for any ns state, this is also a probability, radial probability distribution function. If you take psi, then multiply with 4 pi in case of ns state. So up to that I can write 4 pi mod psi ns square r square. This is the radial probability distribution function, or r square, this is the radial distribution function. This is for all state, but this is for ns state only. Now check for nls state. If we take the psi NLM, where L is not 0, then what happened? If L is not 0, that is, we take the 2pz state. Okay, in 2pz state, that is 2, 1, 0. This is 2pz state. The wave function of 2pz state, normalized wave function, is 4 root 2 pi and z by a naught to the power 3 by 2 into zr by a naught into e to the power minus zr by 2a naught into cos theta. And I have to check that mod psi square r square 4 pi, this is a radial distribution function or not, that I have to check. So for psi 2pz state, this becomes 1 by squaring this becomes 16 into 2 pi and into 1 by a naught cube into z is 1, so r by a naught, that is 1 by a naught square, take outside from the integration, and r square and e to the power minus 2r by 2a naught. By squaring this, z is 1, so squaring this is multiplied with 2. Now this is cos square theta. Now this value cos square theta demands sin theta d theta an extra term for data. So we see later this term. Up to this becomes r square e to the power minus 2r by 2a naught and r square dr extra term for deta. We know that deta for psi, that is r square dr sin theta d theta d phi. This is deta, volume element. So here I have to check only radial function, so radial part. So this is the sufficient integration here. This is extra term. So I excluded that part. Now this is equal to 0 to infinite. What happened here? 1 by 32 pi 1 by n0 to the power 5 into 0 to infinity r to the power 4 and e to the power minus r by a0. So what happened here? The integration of this part is equal to gamma 5 by 1 by a0 to the power 5. This is equal to factorial 4 into a0 to the power 5. So this is equal to 4 into 3 into 2 into a0 to the power 5. Now total integration becomes 1 by 32 pi into 1 by a0 to the power 5 into, this is equal to a0 to the power 5 and this is 4, that is 4 into 3 into 2. So this becomes 8, this is 4, and now this is 1 by 3 by 4. This is equal to 3 by 4, not 1. This is not equal to 1. So we see here that in case of NS state, we can write both terms. That is true. That is 4 pi mod psi square and r square. This is radial probability distribution function, because this is the symmetric function. This is symmetric state. Okay. But 4 and r square, this is also radial probability distribution function for NS state. But for NP state, ND state, NF state, where L is not equal to 0, that is not the radial symmetric function, we use only r square as radial distribution function. This is our result. So for NS function, 4 pi psi square r square or r square, not 4 pi r square, not 4 pi r square, 4 pi r square. This is not a true radial distribution function. That is 4 pi psi square r square. And in case of NP, ND or NF or any other state where L is not equal to 0, that is r square is radial distribution function. So thank you.